with the photographs?
Sir, not PPT, but photographs itself.
Okay.
I have. Yeah.
Okay. So you
Yes.
start projecting the photographs. Actually, what we have done today, students, is that till date we were showing you some online the slides which were available in the website, and the online slides we were showing you and discussing. Today, so we thought that it is not the proper way also. So there are some realistic, the real life photographs that from the Indian basins, which we have collected the rocks and made the thin section, which normally I show in the class to the students to show the different kind of features. Those because the lockdown has ended and now the department labs are open. So Aditi, I am thankful to Aditi that she has photographed those thin sections, and today she will be projecting those thin sections of rocks which were basically collected by us from different parts of India, and then made the thin section to show the different types of sedimentary rocks and their features. So I request Aditi to start projecting the photographs of the thin section.
Um, okay, sir. I'll start with the Arcos.
Okay. Okay, no issue. No issue.
Sir, the screen is visible to all.
It is visible to me at least.
Yes,
So,
sir, it is visible.
Visible.
okay, sir. Okay. So, this is the plain polarized image of the rock. Okay, in which you can see there are quartz grains and some feldspar grains. Also, you can.
The most important thing is that the different
This.
grains are of different dirtiness that you can see. Different
Yeah.
grains are of different dirtiness. Yes.
Yes, and sir, sorting is also very poor. With the grain size is like sub-angular, like that is not properly defined. If we see the crossed polar image, we the cement here you can see the silica overgrowth, like it is seen. It is clear here and in this part, and like there are a lot of feldspar if we see this image, and these yellow grains are the quartz grains. So when the slides remains thick, usually we keep the thickness as 0.03 mm.
Mm.
0.03 mm. So in that case, we clearly get the gray color. Quartz normally shows the gray color, but if the slide remains thick, it sometimes shows yellow color and sometimes blue color also. And so this is the silica overgrowth, and the matrix is also clear in some parts, like here these are very fine grains that can be defined as matrix. This so
Okay. Okay. Is there any other photograph of Arcos?
yes, sir.
Yeah.
So yeah.
So this is another photograph of Arcos.
Yes, sir.
You can see, and then if on the lower right part, you can see a grain which is actually the sweeping extinction. It is showing the sweeping
Yes, sir.
extinction. Now I come to the middle part of the slide. In the
So
middle
this-
of the slide. If you see in the middle part, how is that grain? Students, if you see the contact between the matrix and the grain, that is very, very irregular and hazy and not very open defined. And what I can make out, if I say the other grain which is on the left of it, that may be also maybe the part of the same grain. And the in between the matrix, that is actually, this is called the what we call the pseudomatrix. It is actually the feldspar grain that is decomposing, and it is giving the kind of matrix within the grain. So and the grains which are preserved now, these are as the ghost grain. That means the unaltered part of the grain that is preserved, and some portion of the grain is completely altered to the fine grain matrix material. So if you say it is a matrix, it is actually a pseudo matrix, not the proto matrix. Is it clear to students? Is it clear to students? What we are
Yes, sir.
Yes, sir.
yeah.
Which is the
So
ghost grain or the bigger one, the small one?
both are ghost grain, both are ghost, because they are both part of the same grain. Now there is matrix generation and you are getting the two parts of the grain detached from one another, because in between there is a matrix growth, and the two parts of the grain that still remain preserved and not got altered. So that portion remain unaltered. The rest of the portion, with given time, those portion would have been also been altered. If would have given me more, in between at any stage we have broken the rock and made the thin section. So the weathering was still proceeding, and some portion that is still left which is unaltered. Same thing if you go to the top part on the right side. So top part right side, yes, there also you get a feldspar and then a matrix which is making a irregular boundary. So the matrix and the niche feldspar grain. Yes, this feldspar and the matrix is making a irregular boundary. This is also the half of the grain is totally altered to the matrix, and the rest of the grain still preserved. Now, these are the typical character of the pseudo matrix or diagenetic matrix. We call it diagenetic. This matrix was not formed when the sediment was deposited, but this matrix was formed afterwards by the decomposition of the feldspar. It is also same on the left side, upper left side. The feldspar, yeah, it is also decomposing, and the feldspar is forming, and some portion of original feldspar still remain. The grains are mostly, you can see their roundness is poor. They are not rounded. In many cases, there are edges and wedges, and then the sharp angles of the grains. So that means that number one, sorting is poor, the roundness is poor, high feldspar content. All these, what does it indicate? What does it indicate, students? Hello?
They are not transported much.
No. I am saying what are the features? These two thin sections, what Aditi has shown, what are the characters you are seeing? That the sorting is poor, the grains are not rounded, they are sometimes elongated, sometimes tabular, sometimes with sharp edges. All these they are, and then you have a high feldspar, particularly potash feldspar content. And then if you measure what will be the I estimation, so I estimation करके बताओ what may be the percentage of feldspar here? I estimation. What? Prerna, are you online?
Yes, sir.
What can be the I estimation of the feldspar content here?
More than 35. 35.
You feel that it is 25 to 30% feldspar?
Yes, sir.
Yeah. Okay. So in that case, the naming of the rock that and what was my original question? That what is the this is likely to be mostly Arcos and first generation sediment. Matlab, there is not much recycling of this sediment. So much of feldspar could not have sustained the recycling of the sediment. They are the early stage of the sediment. Okay, Aditi, you come in.
So, okay. This is the same view in the plane polarized light.
Okay.
So, so So this is the same slide in which like somewhere silica growth is clear and the matrix and some feldspar content. So the grain size was very large. So I recorded a video of the entire slide. Okay, I will
Okay, okay.
start that and we
Please show,
can.
please show, please show.
There are a lot of feldspar grains in the entire slide. If we see a particular section, that may give a wrong interpretation if you have a more quartz grain concentrated at one place. So, if you see the entire slide, it is mostly composed of feldspar grains. In this grain, the undulosity was clear of the quartz, and the it is out of focus because of the movement. It is slightly out of focus, and so this is the PPL view of the same slide.
Okay.
Yeah.
Ma'am, that light brown part is the cement.
Oh, which one? Uh, this
Yes,
one?
ma'am, under PPL. Yes,
Uh,
ma'am.
it was just a minute. If you see the cross-nickel view of this portion, you see different like smaller grains are there. Okay, this is basically this pseudo matrix. Some as sir has already explained that feldspar here is getting altered due to weathering. You are getting these pseudo matrix here. Okay.
Okay, ma'am.
And what is happening? Yes, Aditi is right. And what is happening that during this alteration process, the iron is basically coming out.
Yes.
You are
That is.
understanding why it is getting brown? Yeah,
Yes.
yeah. And then that iron is giving that kind of stain.
So, in this grain, if we see these dark patches, these are because of iron leaching.
Iron leaching. Yeah,
Yes.
yeah. There is.
Sir, okay.
Anywhere you fix
Okay.
it. No, no. The previous. Hmm. Yeah, fix it. Fix it.
So,
Yeah,
so
please. Now you see this one on the upper left side. This grain. No, not just below it.
so this one.
This grain. Now you see a typical example of the pseudo matrix. You see this grain. This is the matrix that is generated from the feldspar, and the rest portion of the feldspar is remaining. Feldspar actually is a lathe shape, so that was the actual shape of this feldspar grain. Now some island of feldspar is remaining, and from all sides it is decomposing. On the right side also, upper, that there is a feldspar grain now almost fully decomposed, and it is now looking like a matrix. So if I now count the matrix percentage, I will count all these matrix percentage, but these were not depositional matrix. So now if I see, say, suppose I am calling it a wake. It is a wake because the matrix percentage is more than 12%, suppose, and I am calling it wake. But wake, this naming of wake, that actually talks about the depositional environment condition. The depositional environment energy was not very high, so you had a large amount of mud settlement. You are getting the wake. But actually, is it the case? It is not the case. They were not so much of matrix. All these matrix are diagenetically formed. So this matrix counting, that will give me a wrong interpretation for the depositional environment interpretation. Am I clear, students?
Yes, sir.
Yes, sir.
Yes,
So
Audit.
shall I start? Okay.
You are all seeing the cross-hatchet twinning and the microclean, beautiful grains of microclean.
Yes, sir.
Okay.
So there
Yeah,
are some.
yeah. Huh? No?
So there are some polycrystalline quartz and some biotite grains are also. This is the biotite that is preserved here, and like mostly it is feldspar rich entirely. If we see the slide, so it
The
is like
polycrystalline quartz was there. Is there?
so yes, yes, yes.
Yeah, yeah, yeah.
Mm,
Yeah, we're on left
then
side, left side, left side.
this
This is a typical mass. वही पढ़ रखो.
so just a minute. So this
Yeah, yeah. This is a typical example of polycrystalline quartz. You can see that within the same quartz grain, different domain is showing you different level of extinction. Some are fully extinct, some are partially extinct, some are not extinct at all. That means within the same grain, different domains are in different crystallographic orientation. And because of that, when some domain is going to the extinction, other domain is not going to the extinction. This happens when there is a polycrystalline quartz, a quartz which has the several crystals in it of different crystallographic orientation. We call it, definitely this is, remember this, because when we will be showing you the lithic fragment, siltstone lithic fragment, then again I will ask you, polycrystalline quartz or a siltstone fragment or a chart fragment, how you differentiate it? Do you see this kind of thing in a chart fragment?
No, sir.
No. So remember, this is the basically the polycrystalline quartz. हम लोग बाद में a siltstone fragment दिखाएंगे, chart दिखाएंगे, and then we'll again come back that what is the difference between the three. Because there is every time a chance of misinterpretation. Okay.
okay, sir. I will start. The cement may so there was some silica overgrowth only. There was no other kind
Cement
of
हम लोग
cement.
क्वार्ट ग्रेनाइट का फोटो लिए हो
Yes, sir.
ना, तो उसमें दिखाएंगे ना.
Yes, sir. This is another polycrystalline quartz grain, and this is feldspar.
Yeah.
Sir, this is so this slide is completed now.
Okay.
Yeah. Okay. So so this is also some photographs from Arcos where matrix is clear. They can see
Matrix
the
is very clear.
pseudomatrix. Yes,
Yeah,
sir.
yeah. That what we were discussing there. Here it is more clear what is called pseudomatrix. Here the entire feldspar is totally getting decomposed and the matrix is being formed. The typical pseudo. Students, you must be more convinced with today's slide rather than the earlier day's slide what we were showing.
Yes, sir.
Okay, so now it is we could photograph our own slides and so that we can see it. So
This is the same slide with the, in the plain polarized light. And these resolved boundaries of the feldspar because it is getting altered in the pseudomatrix. And this is the feldspar grain.
So one thing I was discussing that feldspar plain polarized light. Please show it again.
So this.
See, you feel that there is a dirty character.
Yes, sir.
This dirtiness is a typical of feldspar. Quartz will not show this kind of dirty character.
So, um, so here I think we can compare all these are feldspar grains completely like this or this weathering effect is clear in these grains, and if you see this grain, this is not that much, or this grain, they are not that much altered. Or this is also another feldspar grain, completely different from quartz. And this is the feldspar grain with some pseudomatrix.
There are, you can see there are partitic laminae in it.
Yes,
And
so
please fix it here. Now go to the top part, top left. Here you can see there is a matrix on the right side. There is matrix, and there are some higher order color in the matrix. Higher order color, the brown or higher order color. This is basically the formation of sericitic mica. Sericitic mica. So when feldspar is decomposing, if it decomposes, it forms kaolinite, and then kaolinite, when it is diagenetically, it is a very low grade mica. It transformed into low grade mica. They form sericite. So this higher order color, whatever you are seeing, those are the formation of sericitic mica. And when sericitic mica is formed, we then refer to it as epimatrix. Epimatrix. EPI. Epimatrix. Same is on the left, right.
this part.
And उसका और उससे नीचे भी.
So this part.
So there are some sericitization, some fine-grained mica because higher order colors are coming. So that is indicator of some generation of sericitic mica. Essentially, they are pseudometrics, which is diagenetically altered to fine-grained mica.
सर सर हम लोग जब मैट्रिक्स मतलब एस्टिमेशन करेंगे तब सिर्फ फोटो मैट्रिक्स को करेंगे एस्टिमेशन
When you will be, suppose you are doing the eye estimation, and in the eye estimation of this slide, now I feel that the matrix percentage is 10 to 12%. Okay, so I am saying, suppose that matrix, when I will do eye estimation, at that time I will not keep in my mind whether I am seeing photometrics or pseudometrics. I will not do it. I will only see what is the percentage of matrix. Now, if it is the percentage is 12%, I will call it walking. If percentage is less than 12%, I will call it aeronite. Question comes after that what is that 12% matrix? Are these original depositional or diagenetic matrix? That comes under discussion. And if it is diagenetic, why it is diagenetic? What provoked the generation of the diagenetic matrix? Okay?
Okay, sir.
Sir. So you said when the system once you said that when the system is not well drained, then the complex micas are formed. So sir, here can we say that?
No. It is not that case. This is actually that I said. That is the different thing that when you have the clay formation, that is during the clay formation. Suppose when you have a well drained, then you have the kaolinite formation. I said. And if you do not have a well drained system, then the complex clays are formed. Suppose chloride, suppose gibbsite. So those clays are formed. That I told. Here the thing is not that. Here the whole thing is formed in the diagenetic stage. Initially, quartz and feldspar, maximum feldspar with some mica and quartz, they got deposited. And then when they are buried, and during the burial and diagenesis, the feldspar is getting decomposed, and the decomposition of feldspar is creating the matrix or the clay. So it is not that in the weathering profile the clay is forming. No, that we discussed in the weathering profile. Here it is in the diagenesis. Two are different. You understand what I am saying?
Yes, sir. Got it.
So shall I move to the next step?
Yeah, please.
No, sir, all these are from the same slide with different
Okay.
Type of feldspar grains.
Feldspar
Different
grains,
kinds.
yes. Yeah.
This is also feldspar.
And these are some of the deformation laminae in feldspar.
Yes.
And these are deformation laminae. They are deformed also.
So Arcos is, I
Done.
think it's, yes, sir.
Yeah. Arcos is done. Yeah.
So this is from quartzite this is basically,
Yeah.
and mostly it is composed of quartz grains only. With another one thing is prominent here, that grain size is
Bimodal.
yes, sir.
Bimodal.
Yes, sir. It is bimodal.
There is a bimodal distribution.
Yeah.
So bimodal sandstone, students, if people are seeing. Hello?
Yes, sir.
Are you convinced that it is a bimodal sandstone?
Yes, sir.
Yeah.
Yes,
So, and there is a larger mode and there is a smaller mode.
Smaller ones. Yeah.
Okay?
And so angularity of the smaller grains and larger grains is different. And so silica cement contact is also different in both grain sizes, and silica cement you're getting here in some places. Otherwise it is very compact, like there is no the grains are in contact in either in long or sutured at very less silica cement.
It is a grain supported. It is a grain supported rock.
Yes, sir.
And grains are supported either the long face or the point contact, the line contact, and all sorts of contacts are there. And it is as Aditi rightly mentioned, that there is a larger mode, there is a smaller mode. Now, larger mode grains, they are much more rounded compared to the smaller mode, isn't it?
yes, sir.
Yes, sir.
So smaller mode grains, they are more angular, but larger mode grains are more rounded. Now, how you explain that? How you explain that? Can it be reversed also? Can it be reversed also?
Sir, larger grains are more rounded because they are mostly transported as bed load. So
Okay.
and smaller grains could be saltating or maybe in suspension.
Yeah,
So they are generally less rounded.
Yeah, absolutely. If I see just it is just opposite. Larger grains are more angular, smaller grains are rounded. Then, and that also we get. We may not have that photograph, but that happens. Then, your explanation is satisfactory as long as this slide is concerned. Okay. Now I come to another case where larger grains are angular, smaller grains are rounded. How you will interpret that?
So in that case, the larger grains may not be transported. They could be the fragments of some nearby.
No. So the X, how can they be together? Question is that in that case, the larger grain and the smaller grain, they may not be from the same source. If there may be a mixing of source. The larger grains, they are coming from a nearby source, where the smaller grains, they are coming from a distant source, and then they are mixing. So you have then the supply from the mixing of the source, and that is where why the two types of grains did not inherit the same kinds of transportation history. So mixing of source, that is interpreted. You got my point?
Yes, sir.
Everyone is convinced or someone is not convinced?
Yes, sir. Convinced.
Mhm. So this is a bimodal with and the what I expect that larger grains should be more rounded or smaller grains lesser rounded. That is what we are getting here in bimodal. Then as Aditi was showing that there is cement. So in the lower left, where the this thing. Aditi, can you do it a full screen? Yeah. Now you can see it is very good that you can see the dust line. Dust line is clear to you, and you have the quartz inside and the quartz outside, and they are separated by a dust line. This is a typical quartz overgrowth and silica cement. This is what we call the silica cement. This is how the grains are combined with one another, cemented with one another. Everyone is convinced about the cement, how we identify the cement?
Yes, sir.
Okay.
Yes, sir.
So this is actually the silica cement, and the grains are actually are cemented with one another by those. Okay.
Okay, so shall I move to the next
Yeah,
image?
yeah, yeah.
So this is the same in under plane polarized, right? The dust line is also clearly
Yeah,
visible.
yeah,
As you can
yeah.
see.
The dust lines are visible.
Yes. Mm, so here bimodality is
The
also
bimodality is very clear,
very
very clear.
yes.
This is a typical bimodal sandstone.
So this is the entire view of the slide, where one part is basically composed of larger grains and there is smaller grains concentrated in this
So
part.
this is how beautifully Aditi has taken this photograph to show you the total appearance of the slide. When you will see it under microscope, this is how the slide look like. Okay, and we interpret it as a quartz arenite, isn't it? The most of the grains all are quartz grains, but they are in two size mode. One is the larger mode, and there is a one mode, that is the sand mode, another is the silt mode, isn't it? And then they are cemented, quartz cemented. Matrix content is less than 5%, and they are grain supported. The roundness is more in the larger grain, roundness is less in the smaller grain. So all these you have to describe the mineralogy, the cement, the sorting, the roundness, everything you have to describe. You have to give a photograph and then name the rock. This is how we do it.
Sir,
Mm-hmm.
so to have a bimodal rock type, do we always need different sources of?
No, 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 no. Right now, what is being shown to you, it is not different source because it is maintaining the relationship of the transport, as it is being told that the larger grain is likely to be more rounded than the smaller grain. So that relationship is shown here. If it is opposite to that, then the question of mixing comes. When it is not following the rule, what I expect in case of the large and small together. Do you get my point?
Yes, sir. Yes, I got it.
Yeah.
So this is again quartz arenite basically, but with more silica cement and sometimes rock fragments.
Yeah.
And this is like,
And the plenty of quartz cement, silica cement,
yes,
plenty.
yes.
Plenty of silica cement, and you can see here the grain sizes are almost of similar size, very well sorted grain. This is typical character of a quartz granite. They are 100%, they are physically and mineralogically. You are, what is a quartz granite? It is the most matured sedimentary rock, which is mineralogically and physically both way very mature. Physically means there should not be any high amount of matrix. The grains should be in contact with one another. That is there. The grains should be of high roundness and sphericity. That is also there. And all the grains are of quartz. So mineralogical maturity. So here exactly that is being shown, except for a very few lithic fragment. There is a chart fragment. Chart fragment. A chart fragment, is this chart fragment looking similar to polycrystalline quartz? Is this fragment is similar to polycrystalline quartz? No, na?
No, sir.
Yeah. So you can. So you can see this is a chart fragment.
At the same time, there is a polycrystalline quartz also. They can see this is.
The polycrystalline quartz, yeah. So you can see a polycrystalline quartz here and a chart fragment here. So both the things you can see side by side, that how we differentiate between a chart fragment and a polycrystalline quartz. So that is a very good opportunity. And lot of cement that you can see, that the silica cement. So it is a very there is almost no matrix content, and the cement content is quite high. And you can see that the cement that is the left side is come to the left side, low. Niche.
This.
No, the grain with cement all round.
So this.
No, or on right side.
Or this.
Yeah. You can see this grain, there is a dust line all along the grain and the cement on all sides of the grain. That means there were the pore water on all sides of the grain. And that pore water becomes silica oversaturated and precipitated the cement. That means the grain was fully silica saturated solution was surrounding the grain. And in the diagenesis stage, the cementation happened all around the grain. And the grain is in point contact with the other grains. You can see. Now, another grain, which is on the right of it, there is also cement, but the cement is only restricted to some part, not all part, because those parts were in contact with the other grain. So cementation not possible. Cementation only possible where there is a void space. Okay, so you can see that the difference in cement in different grain. On the left side, there is also cement. Yeah, this one. And the dust line you can see. The dust line is very well visible. This is the dust line. And the cement that is on some part of this. So wherever the saturated solution that is coming in the contact, and then you will be getting this cement. Okay.
So this is the same view under plane polarized light.
Yeah.
So another picture of the same slide. And yes, sir. Only these photographs. Yeah. Four. Sir, shall I move to the next slide?
Yeah, please.
So this is also quartzite, but here, like, it is sometimes having some feldspar grains. and completely grain supported rock with sometimes concave or convex contact or
Yeah.
long contact,
Mhm.
and sometimes sutured contact also
Yeah,
is.
yeah. And you can see there is not much of matrix or cement.
Yeah.
Yeah, that is the difference we wanted to show them. That when there is the grain concentration high and there is a what is the difference between the two? In one case there is so much of cement, in the other case there is not much cement. What is the difference between them? Why it is happening like? It is happening because in one grain there may be the burial, the rate of burial, it may not be very fast. In another case, the rate of burial may be fast. So where the rate of burial is fast, there is more compaction of the grain, and grains are coming in contact with one another with very little of pore space remaining, and thereby the concavo-convex relationship, that that means the grain suturing, grain fusioning, all these effects you are getting. So there the burial is fast, so the compaction is fast, so the sediment is losing the porosity, and that's why the cementation chance become reduced and the grains get more compacted. Whereas the other case where the even the mineralogy remains same, but the burial is not very fast. In that case, what will happen? That the sediment will maintain its porosity for a longer time. Then the pore water will become with time more saturated with silica, and it will start precipitating the silica cement. So though both of them, the earlier slide and this slide, they are mineralogically quartz, but you can see the difference between the two. In one case, in both cases, the sorting is good. Both cases sorting is good, but in the second case, the grains are not so rounded. Grains are not so rounded. Okay, so they are basically the higher compaction and not allowing the cementation to happen.
Uh, so this is another view of the same slide. Grain supported and sometimes showing long contact and
Yeah.
concave convex and
And long contact.
yes, sometimes sutured. So, sir, I think it quadrantite must
Yeah.
be clear to this.
So these are the quadrantite. So
Yeah.
these are the examples of the quadrantite that we can. So are you people convinced with these slides, or you want more?
The convinced.
Okay. So these are the slides we actually thought of to show to you. Okay, and there is should we show the lithic arenite also today, or you think? Yeah.
So I have this. I have the photographs. If you will say, I'll show the pictures.
Yeah. Please show the lithic wake or lithic arenite, whatever you want.
So I'll start with the photographs, and in the last I'll show the video also. I've recorded
Okay.
because the grain size was very large and it was difficult to calculate the ratio
Okay.
of the grains. So
Okay.
in this view, there are these are the rock fragments which are basically the siltstone or chert fragments. This is siltstone, this is chert fragment, and with some quartz grains also, and this is also grain supported, but there is very less cement here, which is clear and here, but it is very less in percentage, and sir, matrix is also not present more in this slide, and yes sir, that's it.
Aditi, I'm just coming for 1 minute. You just explain. I'm coming.
Okay. So this is this another view of the same slide where you can see different quartz grains and rock fragments. Okay, so if you see these two rock fragments here, you see the subgrains are comparatively larger if you compare it with this grain. This is the chert grain, which is cryptocrystalline silica, in which the grain cryptocrystalline texture is like very fine grained rock, in which you cannot identify the grain under microscope even. Okay, so this is the chert fragment. Here you can see some grains are visible but not very clear. So this is a kind of rock fragment. This is another rock fragment here, and the contact between different quartz grain is sometimes it's long and sometimes you can see it is concave or convex. And if you see that this is the plain polarized view of the same slide, and this also this rock fragment is showing different character as compared to the other quartz grain, and it is you can see the boundary. This is also sometimes get oxidized, and you can find this oxidized rim. This is here also you can find rock grain, lithic fragment, and some silica cement along with some along with like other grains are, it is quartz rich, and other component, if you see it, it is basically quartz rich, and mostly it is having lithic grains, and grain supported rock with sometimes having silica overgrowth as a cement, and matrix is almost absent, and it's the same.
And so it will be lithic arenite.
Yes, because lithic fragments are higher in concentration. Okay, this is one lithic fragment, this is another, and this is another. Okay, so you will call it lithic arenite because it is basically quartz rich with higher content of lithic fragments. Okay, this is the video. I'll is sorry, is
Ma'am,
there? Yeah.
some of the rock fragments here seems pseudometrics to me. So how we will differentiate between pseudometrics and rock fragments? The fine
See,
grained one.
okay, if you see the lithic fragment, it will look like a class, it will have a boundary, and you will not see the texture as if grain was if there is a pseudomatrix, you will see that this fragmentation of grain, or you will get these altered features as if a grain is decomposing. You will get those signatures, but if it is a class and if it is transported, you will have a class boundary, and there if you will get the oxidized rim also if it is transported, or if it got exposed to subaerial conditions.
Okay.
Is it
Uh,
clear?
ma'am,
Yeah.
ma'am, does quartz also form pseudometrics as we saw in feldspar?
No, not properly, because quartz is very hard to alter. Like it is very resist to the weathering. Most resist mineral to the weathering. If you see compare it with the quartz, feldspar is easy to alter.
Okay, okay, ma'am.
So you that gets very
Now,
quickly.
why it is? Why it is? Let me come to the structure of quartz and feldspar. Quartz is SiO2. It is only SiO2. And what is a feldspar? KalSi3O8, NaLSi3O. So what is happening? That cations, K, Na, aluminium, all these are entering into the structure. So which one will be more stable? Which is without any major cation except the silica, which is on the four-fold bonding, that the coordination bonding with the oxygen. So silica is the most stable and it will never alter in the diagenesis.
Okay, sir.
So this is a video. I will shall I start it?
Yeah, please.
So this is a lithic fragment in which
Yeah.
subgrains are very clear and with different grain size also.
Mhm. The siltstone fragment.
Yes, sir.
So now you think of a siltstone fragment, chart fragment, and polycrystalline quartz. You just,
Yes.
this is a chart.
So this is also a chart fragment, and this is also. So one student was asking the difference between the pseudo matrix, how to differentiate between the pseudo matrix and the chart fragment or another rock fragment. Is it clear to now? Like in this slide, there were many rock fragments with a proper grain boundary, and there was no signature of alteration or this decomposition.
Yeah.
So is it, sir? I want to
Yeah,
ask.
yeah. That is because pseudo matrix will not have a very clear grain boundary, and
Yes.
it will actually fit in between the different grain boundaries. Whereas a chart fragment or a siltstone fragment, they will have a definitive grain boundary. That is the main criteria. So what Aditi is showing, you can see the large number of the lithic fragment in it. This is the plane polarized light. So you can see the large number of lithic fragment, and then if you have more than 10%, 8 to 10% lithic fragment, then we call it because here the matrix, what is the matrix percent? Matrix percent is not high. So matrix is the matrix high? No. Matrix percent is less than 5%, 6%. So it is a arenite. It is a arenite, and because there is a lithic fragment more than 8 to 10%, I call it a lithic arenite.
So this slide is I think yes. This slide is finished.
So we will end today with this lithic arenite. And
So,
hello.
I have one more slide to show.
No, we will show it in the next
Okay.
class.
Okay, sir.
So today what we have shown the quartz arenite, arkose, and lithic arenite. We have described it earlier also. But those descriptions were based on some web-based material, which I personally was not very convinced. So what we did today, we will not give them any task. What they have seen, and we have already given them some task. Let them think about what they have written there. And if they want to revise the write-up, they can change the write-up also. Next day, after we'll show some other slides, we will give these slides for further description.
Okay, sir.
Okay.
Yes.
So earlier, whatever the slides we showed, it was all the features were not very. Suppose arkose, it was not very apparent that it is arkose. There is very high number of feldspar. There the feldspar degradation, and then all these features were not. So now they have seen a arkose, they have seen a quartz arenite, how a quartz with 100% quartz, no feldspar, lot of the silica cement, the high roundness, high sphericity, and how the quartz. And then another quartz where there is absolutely no cement, but the concavo convex contact, the long contact, the Siuchat contacts. So both the varieties we have shown. Then Arcos they have shown. What we have not shown them, that is the Arcosic Wake, where there is so much of matrix generation that it becomes a Wake. That we'll try to show afterwards. And we have showed them the lithic arenite. Lithic Wake we have not shown them. Lithic arenite we have shown them. Now they have to see that what they have described correctly or not. From the next class, we will show this and we will start the carbonate as well. So all of you have submitted your practical, all these exercise in Google class? All, I am telling all. It is not that one or two. All have submitted?
So the last class one is left that we will do today. Otherwise,
Yes, sir.
Otherwise submitted.
Yes, sir.
Okay. So we'll check that also. And I am not giving any exercise today, but you just remember what you have seen today. Keep it in your mind, and whenever you will be discussing this sort of slide, then what are the features to be seen and how it is to be described.
Sir, I have a question, sir,
Yeah,
apart from
please.
this, sir. Sir,
Please.
once you taught us that the cratons host igneous and metamorphic rocks, and you said basins host sedimentary rock. So, sir, I want to ask that, do we see metamorphic rocks in basins also, or they are not even present at all?
No. Basin metamorphism, so when the sediment or igneous rock that is getting buried under pressure and temperature, then you get the metamorphic rock. Okay. Now, suppose I have a Dharwar basin. We call it Dharwar. So Dharwar. Now, if you see the Dharwar, what you are getting in the Dharwar, you are getting the greenstone belt, you are getting the gneisses. This is the general thing, and there are some dikes. This is the only thing you get in the Dharwar. This is the same. If you go to Singhbhum, if you go to Bastar, if you go to Aravallis, this is the same. Three major things. One is the granites and gneisses. Another, some are the dikes. And you people are going through the Picambian stratigraphy now?
Yes, sir.
Yes, sir.
Yeah. So this thing must be discussed. That what is how is if I concentrate on Dharwar. What are Dharwar? If you see the Sargur, the Chittadurga, Baba Budan, all these are basically greenstone belts. Now, what is greenstone belts? They are actually a volcano. What is a greenstone? That is a volcano sedimentary rocks metamorphosed in a greenschist species. That is a greenstone. You understand? So now, if I say that is a basin, yes, they might have deposited in a basin, then participated in different tectonic process, different metamorphic process, and then become the metamorphosed. मेटामॉर्फिज्म तो सेडिमेंटरी के साथ मेटामॉर्फिज्म नहीं हो सकता ना. सेडिमेंटरी इज ए सरफेसियल प्रोसेस, मेटामॉर्फिज्म इज ए एंडोजेनिक प्रोसेस. So you understand the exogenic process. Sedimentation is completely an exogenic process. Metamorphism is an endogenic process. A sedimentary rock can afterwards be metamorphosed because of the different tectonic contour. What is there? You tell me. What is there at the top of Mount Everest? What is there? Mount Everest के टॉप में क्या है?
The glaciers.
अरे भाई ग्लेशियर्स है, सब ठीक है. लाइमस्टोन है, लाइमस्टोन. जो माउंट एवरेस्ट लाइमस्टोन कहते हैं. लिथोलॉजी पूछ रहा हूँ. ग्लेशियर तो है, सबको पता है. टॉप ऑफ माउंट एवरेस्ट इज लाइमस्टोन. कैसे पहुंचा वहां? हाउ इट रीच देयर? माउंट एवरेस्ट के टॉप में कैसे पहुंच गया लाइमस्टोन? वो तो समुद्र में होता है. फॉर्म्ड इन सी. सो ए basin sediment, when it participates in a tectonic process, then it becomes the different tectonic and the metamorphic, tectono-metamorphic process, then that can be metamorphosed.
Okay, sir.
Okay. Okay. Any other thing?
Sir,
Hmm.
yeah, in the first slide for our course,
Hmm.
we have seen a large crystal of large grain of polycrystalline quartz,
Hmm.
but in that slide, the feldspar grains are less rounded, so it indicates that uh, the first cycle of sedimentation. So, how a polycrystalline quartz is present in that our
Uh,
course.
there is no problem in the monocrystalline and polycrystalline quartz. Monocrystalline and polycrystalline quartz, it is actually when the quartz grain is formed, then the question of the any crystal growth, there are two stages of crystal growth. You must remember any crystal growth. One stage is nucleation, second stage is growth. So whenever a crystal is formed, some crystals may be small, some crystals may be large. Why it happens that some crystals small? If I have the nucleation rate is high, in that case, the several nucleation rate, all nucleation point may not grow very high. So you will have small crystals, a number of small crystals. Or if you have the lesser nucleation, then you give more chance to a single nucleation site, you can have a larger crystal. So if in a quartz, I have the number of nucleation points and each nucleation points, it grows by its own right. And that is making the entire crystal, then you call it a polycrystalline quartz. Polycrystalline quartz is not that it is a deformed quartz. Be very, very clear. Polycrystalline quartz can be formed originally during formation. Only that polycrystalline quartz is a deformed quartz when the polycrystalline grains, they are aligned in one direction. What was shown to you, that the subgrains are not aligned in one direction. They are equant subgrain and they can be formed originally when the quartz is formed. So there is no dichotomy between the monocrystalline and the polycrystalline. Both of them can be simultaneously present. No issue.
Okay, sir. Thank you, sir.
Any other questions?
So we did the pseudo matrix and epimatrix examples we saw, but I wanted to identify the proto matrix too.
Yeah. Aditi, you can show from the quartz arenite. I could see in the quartz arenite there is very little matrix, but there is even 2 to 3% matrix even in that.
So, okay.
Yeah.
Sir, is this
No. On left side. No. Then polarized right. You come.
Sir?
On the left side. Yeah. This is these are all protomatrix. These are fine grained material that you are getting in a very small percentage, which is also preserved, and it is not that is a decomposition of quartz. It is the original matrix that is preserved between the grains. Okay? Okay. Okay. So let us call it a day. And if you can have any question, you can revert back to me or Aditi. No issue. We will be happy to answer you. Okay. Okay.
Thank you, sir.
Thank
Thank
you.
you, sir.
Thank you, sir.
Long. Thank you.
Thank you, sir.
Thank you, ma'am.
Ma'am, are you there? Aditya, ma'am, are you there?
Yeah, yes, sir.
Yes, ma'am.
Oh, sorry. Yes, yes, yes.
Yeah. Ma'am, in case if we have any problem, then can we contact you on mail?
Yeah, sure.
Okay, ma'am.
Anytime.
Okay, ma'am. Thank you.
Okay.
Excuse me, ma'am.
Yeah.
Ma'am, the first specimen that you uploaded, ma'am, we didn't find it that it was Arcos. It was a different slide.
Okay.
I think you uploaded it by mistake.